Hi everyone, my name is Jonathan Nguyen. I'm a Principal Security Architect here at AWS. Today I'll be walking through a solution that generates AI-powered insights for Amazon Security Lake, and it's using Amazon SageMaker Studio and Amazon Bedrock. We'll go over some customer challenges I'm seeing, a brief overview of Amazon Security Lake, a walkthrough of the solution architecture, and then we'll get right into the live demo. So in terms of the amount of security data that's being collected, um, that list is continually growing, and the amount of data that is being collected is continually growing. Being able to centrally store that information and then normalize that information into a common framework and schema is critical and challenging, but is needed to be able to actually analyze that data in a meaningful way holistically, being able to identify trends, correlations, any type of anomalies is really kind of key there. And even once you get some of that information all present, the next challenge is having a common understanding and the time it might take to construct complex SQL queries. Um, Not only can it be challenging to understand when to create external tables or views, doing joins versus unions, where should I use a wildcard, what columns should I be looking even within a normalized framework. All of that kind of adds time to either the investigation or the analysis. And all that kind of culminates into being able to effectively reduce the mean time to response during possible security events. Um, Reducing mean time to response means that you can identify the root cause quicker, right? And that will minimize your possible impact within your environment. So with Amazon Security Lake being released, the aim of it was really to be able to allow customers to centrally manage security data, to be able to normalize that data into a common framework, which is OCSF, to compress that data into uh, a cost-efficient storage solution, which is S3. From there, being able to interact with your data from S3 with other AWS managed services such as Athena and SageMaker, which we'll see later in the demo, but then also OpenSearch. This really kind of helped level the playing field in terms of a managed service within AWS that, again, can manage all of your security data, whether it's supported by AWS or not. If it's not supported, then you can ingest that by creating a custom source. So now that we've got Security Lake, that is the main prerequisite to this solution, that it is being set up, the sources that you want to look at are being configured. Once you have that, you do need to share that with a specific AWS subscriber account. From that subscriber account, you are going to need to accept that share and then set up the database within Lake Formation. From there, we've got Secure Lake set up, and you will then need to have the specific model you plan to use within Bedrock to be enabled. Um, After that, everything else within this solution is actually open sourced. In the bottom right, you'll see a link to the blog that walks through this entire solution. Kind of recommend you kind of go there as well as you are kind of looking back at this. So we're creating a SageMaker VPC, so a dedicated VPC that has a internet gateway with a NAT gateway and VPC endpoints for the AWS services that it interacts with. From there, we are deploying a SageMaker domain in VPC only mode with a single user profile and an IAM role associated. We've also have an IAM role to restrict access to create the pre-signed URL, which allows you to interact if you're going into the console, getting to the actual SageMaker notebook. There's a code commit repository which houses the notebook that is available within the SageMaker notebook. And then from there, we've got the S3 bucket for the Athena workgroup will primarily be interacting within from Security Lake using Athena. And so you have to be able to store those queries somewhere. And then from there, we'll jump right into the demo. So now that we're in the notebook, we are going through, all this can be found in open source, so I'm going to kind of skim through this so we can hop right into the demo. But I'm setting up my environment, doing things like creating a Athena engine so the agent can interact with Athena and Security Lake, defining my LLM, which is Claude. You can change out to any Amazon Bedrock supported model here. We've created some custom tools within the LangChain tool sets based off of our use case, things like identifying the schema and then retrying if we can't find the appropriate information, um, leveraging some existing native tools here, creating a custom output parser, which allows us to understand the thought process of the agent, adding a conversation buffer memory, which is helping us to retain the previous questions asked and the results. Here we're just initializing the agent. And the last thing I kind of wanted to go over before we hop into the demo is being able to provide instructions to the agent in terms of how to use both custom and native tools, the sequence of those tools. And you'll see it in the demo in terms of it's going through this iteration of the specific tools and the tool sets. And then here's just a quick synopsis of all of the tools it has available, and then the instructions that we just saw. So to start off, one of the first things I might want to ask are what data sources are available in Security Lake? You can see here that the agent is going to go through and ask itself, do I need to use a tool? What's that tool? And what did I find? Let's back up. It's already given me information. So here's that custom output parser in action, right? It's showing you, okay, which available tool that it is using. Here's the observation, which doesn't really look well on the eyes, but then it will parse that information to have something that's a little bit more human readable. And you've got your finished results and your response here, right? And the importance of having this to be verbose is to understand, well, how is it getting to this response? So from here, I know I've got my some of the native AWS log sources configured in Security Lake, but I've also got some custom ones. So from here, I might ask, what are the top 5 AWS accounts that have the most security hub findings? Again, it's going to go into the agent executor chain to list out the tables to say, well, what's the table that I'm gonna use? So it is identifying the security hub findings Athena table. And then next it's looking at, I'm going to use this tool here, which this is a schema and sample rows to get real examples from that finding table to say, well, if I'm looking for Security Hub findings, looking for the count of that, which column should I be looking for? So here are some example columns that it's getting. It's running the creating a external table, and you see here is the OCSF columns. Now it's finding, telling you, well, to get the top five AWS accounts, this is the thought process, right? And this is important because if it's thinking about it wrong before you get to this SQL query down here, you can kind of tune it to say, well, maybe I need to change a custom tool, or maybe the native tool needs a little bit of tweaking for my use case. So from here, you see that we've got the SQL query, and we've also got the results here, which aren't really human readable. And then you've got, this is the thought process that it's going through, and here's the end result, right? This is important because you can start thinking about, well, where should I go focus? Which accounts, because of, hey, this one's got a ton of security findings, should I focus there? Before I go there, I might look at, well, just copy and paste it here. So within those AWS accounts, were any of the following actions found in create user, create access key, delete trail in CloudTrail? Why do I care? Primarily because these are some highly privileged actions that might denote some type of privilege escalation. So again, going through, looking at which tables are available, finding the tables, and well, where do I need to go look? So it's looking in the CloudTrail table within Athena, and now it's going to get some sample rows to figure out, well, which column, if I'm looking for specific API actions, should I look at? So going through, getting some example columns from that table, and then you've got a SQL query that it is crafting to say, well, remember the account IDs that we are looking that were in scope. Remember, I didn't have to pass this through. It's remembering based off of the buffer memory that we um, did earlier within the notebook, and it's looking within this column, right? So API operation, these are the actions that I was looking at. So you see that we've got an error, right? And it tells you this is the response I'm getting from Athena, but it actually explains what that error might be, right? So this is an error based off of the SQL query that was created. And so we've got this retry mechanism based off of the other, the SQL DB query tool that we customized, because this is kind of what we saw, right? We didn't want to go back and have to ask the question again. So it's going in, trying again to say, okay, well, let me go look at changing the SQL query to get some information. So this time, it's good, right? So it's telling us, here's the results from that SQL query, which tells us that here's the accounts, and then here are the counts of the specific events that we're seeing. Um, and you see that you've got the accounts, the number of events that you saw for each one of these things. So from there, the next question I might want to ask is, what are the IAM principles that took those actions? It's going through to see, again, you've got this progression, and this is basically instructions we told the agent, right? Make sure you know which tables you're looking at, so you're not referencing phantom tables that just don't exist. From there, identify which table you are going to find information in. Again, we're still in the CloudTrail table, and then from once it knows which table, it's like, well, get some schema and sample rows so you're looking at the right columns ahead. So from here, you can see that it is crafting a query, and again, it's looking at a specific column and showing that, well, this column actually doesn't exist, or we're not authorized to access that resource. So let's try it again. And it goes again to create a new SQL query to determine how can I find that information. Again, we've got another error, and this is basically because the SQL generation of the ask is either incorrectly created or looking at the wrong columns, right? And so it's really important to have those tools available and customized for your use case, basically to make sure that you minimize this as much as possible. And it's also important to make sure that you're validating these things, and that's why we want it to be to have this to be verbose, so it shows you not only just here are the results, but how am I actually getting those results. So um, here it is looking through another SQL query that it's crafting. You see again, it's just trying again and saying that, well, am I getting the information that I'm expecting? All right, so from here we've got a number of queries that did pass, and you've got a mix of some of the assumed roles, and these are roles that we created just for the purposes of this exercise. One of the last things I wanted to show, so any of the questions that we asked earlier, for example, what are the top 5 AWS accounts, the most, you can ask it to plot the answers as well. What that's really going to do is it's going to go through that previous iteration of, hey, list the tables, go through, get some sample rows so I can understand the schema. Use that information to uh, be able to understand the columns that are within that table, like so. And then from there, craft a SQL query based off of that understanding, which it will go through and get that information. And then also, here we go. So here's the steps that it's taking. It's got the SQL query, um, and it's going to be able to plot the results. So it's going to ask, we will just answer it. So it's asking us a question to validate everything that it's kind of trying to do. And it's also giving us this, it's going to give us a code snippet, which we can then use later on to actually create this visualization. Um, Same thing here, right? Going through the same iteration, the thought process that I just talked about. From there, it's getting the information for the SQL query. It's going to generate that SQL query for us, kind of similar to before. So we've got our results. Here are the results in terms of the Security Hub findings, sorry, the accounts with the most Security Hub findings, and it's going to kind of continue on. It's going to give you this warning, right? So it's the code that it's going to create for us, which is right here. So if I get this information, and what I will do is it's going to tell us that it's not going to execute Python code directly. So what I have here is I took that information, I put it in here, and if you run that, it's going to, sorry, I got to stop this here. Um, and so if I run this here, you can see again that it's going to give us this visualization. From here, you can do things like export your investigation to show, hey, this is kind of the thought process in terms of how we had conducted this. With that, that concludes this video. I want to thank everyone for allowing me to show you how you can generate AI-powered insights for Amazon Security Lake using SageMaker Studios and Bedrock.